Here we go. We're going to take a look at the honors. Number one here. It says R and S are graphed in a coordinate grid as shown. Based on the information you graph, which statement is true?
A.
R and S are parallel lines. What do you think about that one?
Yes.
Okay, what about B? They're perpendicular
No.
lines.
Oh, as well.
That's absolutely not true. R and S never intersect.
No, they won't.
No.
They would never.
Lines R and S are neither parallel nor perpendicular.
They're parallel.
Okay, well, if they're parallel, would they intersect?
No.
There's no way one of these could be true without,
They're being true.
well, actually, lines could be skewed, but not in the same plane like this. If they're in the same plane and they never intersect, then they are also parallel. How can both be true? They can't. So, which implies, which one's gonna be our correct answer? It should be D here. Now, here's what this means. Though they look parallel, they're not actually parallel. Let's just prove it. Does that look like a pretty solid?
Oh, yeah, I
right there?
kind of see it.
And that look like another going one?
Yeah.
What's our rise here? 1, 2, 3. Okay, I want to draw like a triangle this way. So we go 3 up. 1, 2, 3, 4. 3 over 4. Okay, let's try to find a good one here. Maybe there.
-3.
And maybe there. So it goes up 1, 2, 3, and 4. And over. So are they parallel?
No.
No, it's not parallel. And so just make sure you read your instructions because you can't have both of those, one without the other. Okay, so that's D number 1. All right, let's take a look at number 2 here. And the figure M is the midpoint of AD and BC. So what does it mean if it's in the middle?
It's the midpoint.
Okay. So what does it mean about the
Oh.
figure?
They equal the same.
This cuts in half. So if M is the midpoint, then these cut in half. Would you agree with that?
Yes.
Yeah.
And if BC, if it's in the middle of BC,
That means.
these two are cut in half. Do they have to be congruent to one another? Not necessarily, but I'm waiting. No Christian knows this because I've heard him say it a bunch of times. There's something else in this picture we could add in.
Vertical angle.
We have vertical angles. These two here are vertical angles. So what, let's look at the triangle on the left. I have a side followed by an angle followed by a side. That is side angle side. So the answer is B. Questions on that?
No.
Okay, number 3. The lines and the rays in the figure are coplanar. What does that mean to be coplanar?
They're on the same plane.
Same flat surface. Line P is parallel to line Q. That's what these lines mean right there. Based on the information diagram, what is the measure of angle 1?
So wouldn't 63 be the same as S? Like I'm saying about
Here?
corner, yeah.
Let's see. Could 63 be here?
Yes.
What's that called?
Vertical angle.
Okay, now if that's 63 here and we continue this on this way, 63 would be right here, which would be called what?
Corresponding.
Alternate interior. And then 63 would be here. Now, can we say that just jumps across over there necessarily? No. We could say this is 148, so what is this one right here?
148.
And now what we could do is, this is a linear pair. So you think about it that way. Yeah, what is 180 minus 148? 32? Okay, so that's 32. What can you tell me about this one? Now we're getting really close. I drew this with this dashed, dotted, what was supposed to be line and curve thing right there. How many degrees would be in this triangle? Because every triangle, excuse me, has 180 degrees. So can we figure out how many degrees are there? Here, 85. We got 180. You subtract 63 and you subtracted 32, and we got 85. All right,
Yeah.
great. If that's 85, how could we find angle 1? This is what do you call that? A linear pair. So it'd be 180. Every line has 180 minus 85, and we get 95. Answer is
Wait, Mr. Beck, how did you know that 63 went over?
If you drew this as a, this, if you continue this transversal is what it's called. Let me use a dotted line. If you made this transversal continue, just like that. Then it would be alternate interior angles. See how this is parallel to this? Here's our transversal. If I had 63 here, I have to have 63 there because of alternate interior. This is the interior. And you're alternating on this transversal right there. So that makes sense now.
It's just draw it.
You can keep drawing out that straight line. Yep, just continue it on. Bye.
Because if you
Okay.
straight up, it's gonna go.
Now, I'm not gonna say that's the only way to do this problem. I'm sure you could think of another. You could probably say this is a linear pair and work from there. Or continue this one down this way. But there it is. Yeah, now that I think about it, we could have done it that way. You could have done the same thing here. You could have drawn this one, extended this one out. And if you extended this out this way, see how we have 32 there? Where would I put 32? There or there?
On the inside.
And again, notice our triangles is how we have 62 or 63 and 32. 63, 32. We do the same math, we'll get 85. And again, you have a linear pair. So yeah, any of those ways could have done it for you. Okay. Jaden. Whitley, make sure we're working here. So diagram shows the RQs to construct PQ given JK and point P.
JK.
So here's JK,
Yay.
and the RQs to construct PQ. Now, what did we do here?
A circle.
Which construction is illustrated in this diagram? This be. So you're given P and you have this arrow. You measure this out and you draw this arc. What did we just create? PQ, what would that be?
A line
A
segment.
segment bisector.
Is this a bisector of what? Bisector means it's a segment getting cut in half. That's actually
Was the little gray line, did you draw that, or was that?
this. It was there. So that's what you drew. You put like a compass down here, one end and the other, and you made this mark to figure out where it intersects this line.
I think it's,
Would it be a congruent?
It would be a congruent segment. See how that would be equal to this? We just created a
Was it right?
congruent segment. That's right. It's not a bisector. Did this cut it in half? Did not get cut in half. You could say, are they parallel? Well, yeah, but did this actually tell you it's parallel?
No.
No, that's just showing you that the equal distance. It's showing you the distance anywhere on this point, this little curve would be an equal distance between that JK would be equal to P in any of those. That's just showing you the equal distance. So it's not parallel necessarily. And perpendicular, does it make a T in a 90? That was the worst answer of all of them. So that's why it's congruent. All right, let's go to number 5. And trying to move it fast here. It says in the diagram. Sorry, let's move that. In the diagram, EDA or EAD, sorry, EAD is congruent to EAF. These are congruent, which means this is a
Angle bisector.
bisector, angle bisector. Measure DAB. DAB here is 6x plus 14. I'm gonna write that in. 6x plus 14. And BAC is 4x plus 6. BAC is 4x plus 6. Based on the information diagram, what is the measure of EAF? EAF. We want to know this angle right there. Okay, let's start with, could we solve for this x?
Yes.
Yes.
How could we solve for x?
It's those equal to.
These two are equal to each other.
Are they?
Do they look equal?
No, they're not.
They add up to 180.
They do add up to 180. That's fine. Yeah. So let's do that. So 6x plus 14,
Equals 4x plus 6.
not equals,
Plus
mean, yeah,
4x plus
plus 4x plus 6 equal how much?
180.
180. All right. Deo. Deo,
Me.
come back here. Come with me. All right, let's, what do I have in common?
What did it say?
6x.
Yeah.
Yeah, these are on the same side, so I don't have to do opposite, they're on the same side. Kevin, I need you to work in as well. What's 6x plus 14? 6x plus 4x?
10x.
10x. 14 plus 6. Dave, I need you to go back with me. It's a couple times now you've been sleeping away. All right, so how do I solve from here?
Minus 6.9.
Now, why am I doing opposites now?
Because they're on opposite.
Okay, because up here they're on the same side, so I did the same sign, you see, now they're on the opposite side, I'm trying to get rid of that, I'm gonna do the opposite. So it's 10x equals 160, and finally, last step, oh, this isn't the last step. This gives us x, which is not the last step, what is x then? 16, all right, great,
Wait, Mr. I know what to do next.
okay,
So, you input 16 to the 4x plus 6 because it's, vertical with,
So that-
80.
yeah, that matches, okay, so what is 4 times 16 plus 6 more? 4 times 16 is,
64.
add 6,
50. Yay, I got it.
70.
64 plus 6 is
70.
70.
Oh, it's 64. I
Hmm.
thought it was 40.
And I just went along with it. No.
Somewhere, something's not right here.
What do you mean?
What do you mean?
Because wouldn't,
Okay, well, it's acting like it's right, but that just, does that look like 70 degrees?
No.
Oh, that's what I'm saying, something's off
so, it
here.
doesn't matter what it looks like.
Yeah, I guess not, but
You can't assume this.
Yeah, you can assume.
Are you shutting them by their appearance, Mr. Forty?
that's
No.
what I experienced, but does it say not drawn a sale?
No, but it says we're looking for.
We're looking for.
Oh, this is 70. Are these congruent to each other though?
Yes.
So if that's 70, guess what this is?
70.
That's 70 as well. It just does not look like 70, 70. That's just crazy, but whatever. If they're gonna do that, they're gonna do it. That way. That's just why, because if you went ahead and solved all the way around, you know how many degrees are left over for right here? 40. Does that make sense at all?
Yes.
According to their diagram, this is 40.
The smaller angle. If we solve for the vertical angle, then that entire piece is gonna be inside bicycles.
No, it's not this whole thing though. It's this one straight across. It's these two lines. Yeah, that's crazy. They just did not draw that scale at all. That's pretty bad on there, on the drawing part. All right, well, either way, we're moving on. That's how you do it. A conditional statement is shown. If 2x
Wait, but Mr.
minus 5 is 13, then x equals 9.
So that's the way you do that problem? Even though-
That's how we do it, yeah. That's how you do that problem, just like that. No, it is the right answer. It's just. Sorry, one more time. And I posted these online, posted online as well.
On YouTube.
I'll send you the shared folder. I have it on YouTube. Yeah, I'll send, don't worry. All right, conditional statement is shown. If 2x minus 5 equals 13, then x equals 9. Which statement represents the inverse? If x equals 9, then 2x minus 5 equals 13. If
So-
2x minus 5 does not equal 13, then x does not equal 9.
It's A.
It's B.
Well, let's go through.
It's B. Oh, it's B, the inverse doesn't flip the.
Oh,
Yeah, it's B.
It's B.
A.
It is B.
Yeah.
What's this one called if you flip the P and the Q? We call it B.
Converse, I mean,
Converse.
Converse, yeah.
This is the converse. If x is not 9, then 2x minus 5 is not 13. What's that?
Contrapositive. I don't know why I said it like that.
Not your
Contrapositive.
This is the inverse. So what does that mean? This is x equals 9, if and only if.
What?
2x minus 5.
Ew, I don't even make sense.
We don't do if and only ifs. So that's
Is that
it.
actually-
Yeah, you do that, but that would mean it's true both ways. Okay, and only true both ways. All right, number 7. AB is shown on the coordinate grid. What are the coordinates of the point 2/3 the distance from A to B? So where do we start from?
A,
Tell me when you approximately think I've gone 2/3.
wait, what you're going to do?
That's not too dirty.
That's what's going faster, okay.
Okay, that's good.
All right, somewhere in there.
Yeah, it's all right there.
Okay, now what is not reasonable?
A,
B,
wait, no,
Actually,
no,
A
no, no,
makes sense.
sorry,
B is absolutely out. That would be the halfway point. That's B. That's, let me draw it as next. Here we go. That's out. C is out. C is probably 1/3. 1/3 of the way, or 2/3 going this way. That's my guess. So C is out. Okay, so it's either C or it is
A,
D.
I mean, that's what I meant,
I
yeah,
mean, I'm sorry. Did I say C?
yeah, you said.
I'm sorry. I meant it's either A or D. So how do we find out this for sure? Yeah. Can I like, I'm gonna call it triangle it? Help us out. What's our height here? What's our rise? Or what's our negative rise here? What should we
Wait a
call
minute.
it?
That's 9.
We were at 9. See, now we're at negative 9. We fell 18. We were at -6. Now we are at 4.
what's a 3 missing? 8.
-6 to, okay, you're right. -6 to 3.
That's 9.
That's 9 units. So what is 2/3 of -18? Sorry.
6, 12. 6, 12.
Okay, I think it's easier to divide first. What's 18 divided by 3?
6.
6. So it's -6 times 2.
Negative 12.
So we should fall 12. And then you also take 9 and multiply that by 2/3. 9 divided by 3 is 3. Multiplied by 2. So it's 6 units over. 6 units over would be from -6. That would get us to A. A is the correct answer.
Yeah.
Yeah, we did stop right on there. You know, we're pretty accurate on the 2/3. Okay, let's look at the next one. 8. A conditional statement is shown. If two angles share a common vertex, what's a vertex?
The corner.
It's the corner, okay. Then they are adjacent. Which diagram represents a counterexample?
Counterexample?
Yes, what does counterexample mean?
It means the first one's not necessary, I mean, the first one's true, the second one's not necessarily
Yeah,
true.
it's proving the statement false. Proving false. To prove false, you use the first, the if statement, but you prove that the second is not accurate. So which one do you think it is, Guadalupe? He says D. Jaden, why D?
Because I had confirmed with Guadalupe, but anyways, like, cause they share a vertex, but they're not adjacent.
They're not adjacent. What do we actually call that?
Vertically.
Vertical.
That's vertical
Vertical.
angles. But they don't share. Okay, do these share vertex?
Yeah,
What do you call them when they're like that?
adjacent.
Adjacent. You could also call it, what are some other names?
So, Mister, what's an example of Jason?
When they share the line.
Like
Adjacent,
that.
you can share like a line like that. That's adjacent. You could also call this supplementary. What does supplementary mean?
It means it makes 180.
What else could they call these? That might be it. That could be it.
Look like the right angle.
They look like right angles. That's good.
What Mr.
Well, we need a second, you need a parallel line. So we need it. I was thinking about that at first. You need a parallel line, and then you start talking about that, but we don't have one. Okay. 9, a triangle ABC. Oh, goodness.
Oh, geez.
Kevin, where's your phone? Is it on that other desk
Look at you.
or in your lap? Put that phone back over. Oh, damn. What does this symbol mean right here? See, what does that mean? Line mean right there? I'm sorry. What does this symbol mean? Parallel. These are parallel. That's what the big arrow is indicating. D is parallel to AC. Basic information. What is the measure of ADC?
ADC.
ADC right here. The hell is it?
Oh, there we have this thing.
Okay, let's figure this out.
Oh, so those two lines are equal. I mean, they're the same degree.
If these two lines, you're talking about,
No, I'm saying the 42.
okay, if this is, because it's corresponding
Yeah.
here,
Yes.
that has to be 42, I agree.
For the 42 plus 42.
That's 84.
284, and then 84 minus 180.
Would be 96.
Then below height.
What's the little triangle thing?
Then the
Right here?
height.
Yeah.
Here,
The middle is like that one.
so it's just the way they drew it. This is just how they intersect. You said 96?
Like the play button looking thing.
Yeah, it looks like a play button.
Oh, they're saying these are parallel.
Oh.
This is parallel with this one. So that's 96. What else can we know? Now that we know that's 96.
And then that
vertical
is
angle.
This is your bear.
180 minus 10.
Ah, good. So this angle is 180 minus 96, which is how much? 84. So 84 goes here. We now have enough information to find this one.
No.
Why?
We only have 1 degree, that's what you said.
I know what to do. Do you?
The 50, the 180 minus
Go up to the top.
180 minus 50.
Okay, these two are gonna be the same. So it is, you take 180 minus 50, what do you get?
130. Yeah, 130.
180, whoops, minus 50,
130.
I didn't do it.
130. Now what do I do with that 130?
Right, right, 65.
Okay, now what that tells us, because these are parallel, these should be corresponding. If this is 65, what should the total of this be? 65. So how many degrees would go right there?
Wait, why is it?
Because they're corresponding. You have parallel, parallel with the transversal.
Or so you could just do 180 minus 65 to find that, right? Because it makes to find the 80 line, right?
Well, that would be this whole thing. We don't have anything in there yet. So
No, but I'm saying.
this whole thing is 65. What's 65 minus 42?
43.
So 23 goes right there. That's 23, because that makes 65. How many are left over for there? We're finally to our answer. It'll be 180 minus that 84 minus 23, we get 73.
Woo, hold it. Almost not.
All right. Which conditional statement has a false by conditional? Y'all remember what that meant?
Yeah, but if you flip it, it'll be.
If you flip it, it's a false statement. That's right. So like saying the converse is not true. If all 3 sides of a triangle are congruent, then it's equilateral triangle. Okay, let's flip it. If you have an equilateral triangle, will all 3
Yeah.
sides be congruent?
Yes.
Okay, so that's,
A regular
that's a true statement. So since it's true, I'm gonna do this.
B's.
Let me go with this. I'll say this is a true statement.
I think it's. B's
We're looking for a
false.
false statement. Okay,
B is false.
so you're saying
A
if
real
you have a
polygon.
regular polygon,
All sides are congruent.
all sides are
No,
congruent. That is true. If it's regular,
Yeah, they don't really-
sides and angles are equal. So angles are equal to each other, sides are equal.
what if you said, we're talking about that was house. Oh, I remember.
True, a house is not regular.
I know, but I'm saying when you were talking about it, all I
Okay.
remember was the house.
So if you have a regular polygon, all sides are congruent. Okay, what about the next one? If you have a square, all sides of a quadrilateral are congruent.
Yeah.
Okay. If you have an isosceles trapezoid, what does that mean? What's a trapezoid?
Like a,
It's like a slanty break.
it's like a ramp.
Look over it.
But the what's
Okay, if it's isosceles, what's that telling you?
No,
So it could be the top and the bottom. No. So, okay, if you have isosceles trapezoid, then the quadrilateral has only one pair of opposite congruent sides.
So I don't forget.
Would this be considered,
One is shorter than the other.
could you do an isosceles trapezoid this way?
That's how you.
That's not a.
Okay, what would that be called? Okay, just making sure. So, let's see, it only has only one pair of opposite congruent sides.
No, a trapezoid has two.
Parallel.
If all the other ones are true, this one has.
A trapezoid has two. Congruent sides.
But they all true.
The top and bottom are not congruent.
No, they would be different side lengths. They'd be parallel.
Oh.
I say we skip this one.
No, do
Well, let's
you?
think about it. We missed something somewhere. Well, let's go back, let's read it the normal way too. If all three sides of a triangle are congruent, if all three sides are congruent, what is it? Equilateral. If all sides of a polygon are congruent, it is a regular polygon. If all sides of a quadrilateral are congruent, it is a square.
I wasn't even looking at you, I just know what that is.
Yeah, wrong.
Here, diamond or rhombus.
Yeah.
Yeah.
You could have all the same length. These could all be the same length, but is that a square? There you go. Rhombus, it's like a square, but it's not all 90, so you slanted. So it would be a parallelogram, but it's actually all the same. Yeah. That's the answer is C. So, biconditional means it's not. We're gonna say that what that means is that it's not true both ways, both as the converse and its inverse. Not, I'm sorry, conditional and converse are not so true.
It looks like the four is the same.
All right, moving on. We're gonna check that real quick. We check that one.
And so.
What number was that?
I'm like,
Oh my God.
oh.
10. Yeah,
That is.
it's 10.
Oh, wait, is that our beginner?
All right,
Actually goes into.
want to see your formula chart?
Yeah.
All right, we'll pause here. We'll go to the formula chart. You will have this built in. It's under the resources. There's like a button. I don't know if you've noticed this before when you take School City. It's there. So your formula chart, let's see what's on there. So we're in rhombus. Let's see if anything, we're not doing area yet. Volume. We didn't do any of that. Polygons, okay. If you want to know how many how many degrees are on the inside, what does N mean?
Genesis?
I don't know. This hasn't come up on any lessons, so I'm guessing this is second semester. The N is the number of sides. So if you want to know, for example, a triangle has how many sides? 3. So you put a 3 there. A square has how many sides? 4. You put a 4 there, and so on.
Wait, what is N mean?
The number of sides.
Oh.
Number of sides. Okay, and this one we did have used. I know we used this in one of our lessons earlier. We haven't used it on the example questions. But the exterior angles, you take 360 and you divide. That was on Delta Math quite a few times. What is N one more time? Number of sides, okay? Yeah, it was when we were doing the rotations. Are we doing transformations to rotations? If it was, how much of a degree turn was it?
Oh,
You take 360 and divide it by how many? Okay, midpoint formula, midpoint's on there, there's midpoint,
distance.
there's distance, which you could also draw it like a triangle if you want to do it that way as well and use Pythagorean theorem. Slope is given to you. Slope intercept, point slope, we did that first base. We have not done standard form of the line, but that's on there. Equation of circle week, that's second semester. Pythagorean's there. All right, here, sine, help me out. What was the thing we said? Sine is,
Y over.
sine is y, cos is, tangent is, what's missing? Silent H. Yeah. So sine is y, cos is x, tangent is. All right, so notice, did they follow the rule? Did they put their theta on the x-axis?
No, they did not.
Yes, they did. A, X, Y, H. Special right triangles, there they are. They have both those for you. Long signs, we didn't talk about that. That's very powerful. We'll talk about that in pre-cal. And probability second semester, so that's chapter 12, I think, or 13, something like that. All right. Anything else you want to look at on there? Oh, you can't skip pre-cal. Why do you want to skip pre-cal?
Can we just skip that?
John is making a map of his neighborhood on a coordinate grid. He plots the park at -3, 4. Where's -3, 4? There's two directions.
To the left and yeah,
Left,
to the
up. Okay, there's the park,
Oh.
library, 4, -1. Where's 4, -1?
Right, and then
Hang on, we're almost done here. In the grocery store, -8, 4, 5, 6, 7, 8, and 6. 4, 5, 6. There's the grocery store. If each unit represents 2 blocks, how far is the library from the grocery store to the nearest block?
let's count. 1, 2.
Okay, so this point, the grocery store, it's -8, 6, and this one is,
4, 1, negative.
so we gotta find the distance. What's our rise here, going from 6 to -1? It drops 7. Drop 7, and what's our run? We were left 8, now we are right 4. No, we were left 8, now we're right 4. Well, we're running 12, so how do you find the distance between these?
Stop looking.
How you get 11, and then 8? 8 to the left, 4 to the right.
That's 7.
Okay, so it'll be, you don't have to, now that I drew it as a triangle, I'm gonna look at it as a +7 here. It would be 7 squared plus 12 squared equals, all right, off the top of your head,
49.
49.
4 is 193.
Good math. 193 equals c squared, so take the square root of that. You're 13.89. Now it says if each unit represents 2 blocks, this is what's weird in this one. If each unit represents 2 blocks. That's how many units apart they are. So we need to multiply this by 2. Why do I need to multiply by 2? Because there are
Do something in a something.
2 blocks
Yeah.
into
Some.
1 unit.
Yeah.
And so if I multiply by 2, 13.89 times 2 is approximately
It's really-
28.
Wait, but why do we have to multiply them?
Because it said each unit represents 2 blocks. So it's kind of tricky. At the very end, you have to double it.
I got it twitch in my ear.
No, you know what makes sense when you say